So we have had the 6 presentations, and now we will move on to the discussion session with online and offline participants.
지금까지 발표했던 내용을 가지고
So based on the presentations
새로운
so
토론자를
far,
불러주고
we are going to invite the three
MT가
panelists
6분과
for
토론자
discussion,
15분과 함께 앞으로
and
40분간
six speakers will
토론을
also join,
진행을 하겠습니다. 우선
and the discussion will
먼저
take place for about 40 minutes.
토론을 하기 위해서 세 분을 추가로 모셨습니다.
So we invited the three panelists for the
첫
discussion. The
번째로
first panelist
산업기술평가관리원회
is from
민철 PD님을
KEIT,
소개드리겠습니다.
Mr. Yu Min-chul.
Please check the microphone. It doesn't work. We have some technical issue. I'd like to ask for your understanding. Due to some technical issue, interpretation is not being provided. I'd like to ask for your understanding. I'm sorry, there was some technical glitch. I am Min-chul Yu, a program director at the Korea Evaluation Institute of Industrial Technology. I'm in charge of national R&D planning in the field of shipbuilding and offshore platform technology.
The second panelist is Emeritus Professor Hwang Il-sun of Ulsan Science Technology University. So good afternoon. Currently, I am researching the small-scale reactor for shipbuilding solution, and thank you very much for inviting me. And the third panelist is from Korea Register, from the System Safety Team, Dr. Lee Sang-rae. So good afternoon again. I am working for Korea Register. Korea Register is registered as the performance assessment agency for wind power and RPS, as well as the floating offshore wind power and also the renewable energies. We are conducting researches on that. So for the discussion, once again, I would like to thank all the three panelists. This discussion is now taking place in hybrid format. So Vice President Lee Gang-gi of AVL is joining us online from Austria. And Monica Alvarez Cardozo from DNV, the speaker. Because of her personal reason, she could not join us today. And the Yu Byung-yong, Director of Hyundai Heavy Engineering, and also the Song Kang-hyun from Korea Register, and Kim Man-woo, Busan University Professor, Bae Jung-chul, President of the Korea Maritime Equipment Institute, will be joining the presentation, or rather the discussion. So if you do have any questions, please type in your question in the chatting window. Then at the end of the discussion session, we will open the floor. We will have the Q&A session. Now we will first hear from Yu Min-chul from KEIT. Then we will give the chance to the presenter to answer the questions.
As I listen to the presentations, I came up with some ideas for questions. My question to Ms. Monica Alvarez, I prepared some questions, but I believe some of the presenters might be able to address the questions here. Otherwise, I think about this. I can present my questions as food for thought.
한 가지는 저희가 미래의 이제 친환경 이제 사회라고 이제 표현을
When
하면
we talk about eco-friendly society
green
in the
ammonia
future,
내지는
we frequently talk about green hydrogen and green ammonia and various energy
수요가 각국
demand. Each country has its own energy demand, and IEA also talks about the energy outlook, energy demand outlook in 30 years' time and 50 years' time.
이런 이제 전망들을 좀 하고 있습니다. 이제 그런 이제 이 미래의 에너지
But as for the future energy option,
같이 얘기되고 있는데
what is
그거를 이제 이루기
discussed at the same time is the technological capabilities, how mature technology will be in order to realize the feasibility and economy of such an energy option.
얘기가 됩니다. 그래서 지금 오늘 이제 발표하신 분들이 이제 그 중에 이제 그 친환경
So the presenters today talk about ammonia
이제 선박 관점에서
from the perspective of ships.
필요한 기술이나 얘기를 좀 해주셨는데
The presenters talk about the technology and technological requirements we have to realize.
선박 관점에서 사용할
So from the perspective of ships,
연료가 있지만
there is some energy or the fuel requirement, but these energy and these fuels would be required by any other industry as well. So there is such a high demand for a limited energy, whether it's ammonia or hydrogen. There are some technical and technological challenges, especially when it comes to ammonia.
일상에서 전반적으로 이제 많이 사용을 하게 될 때
When we use it in high quantity onshore, there are some challenges, including toxicity. The same goes true for ships as well on board.
드는 게
Another area of concern or the challenge
냄새에 대한
is the odor.
우려가 있는 것은 사실입니다.
We have to acknowledge this because in a limited space, if we are to use this in a limited space of a factory or a ship, that this did not cause any controversy or any heated discussion on this matter. But if we use this in our day-to-day lives, how can you reduce the odor and how much it will cost for us to reduce the odor? So this, I'd like to know whether this kind of cost is incorporated into the price of ammonia. So since DNV is doing the comparative analysis of the future fuels, this is the question I planned and prepared for the speaker from DNV. Since Ms. Cartozo is not here, if there is anyone from the presenters who can answer this question, please. May I address the question? Yes, please. Not as the one who represents AVL, but as a member of the Greenhouse Gas Emission Reductions Strategy Committee. We have conducted a research on this matter for the past 2 years. So, as you just said in your question, we've looked carefully into this matter. When we consider a new energy option, we have to first introduce new rules and regulations. Currently, it's tank to wake. In this case, we cannot consider and calculate the costs associated with associated and incurred through to the entire supply chain, but in this case, we have to check the well to will and a well to wake in order to make an apple-to-apple comparison. So, containing this, we've been prepared a position paper and then presented this to the regulatory body, responsible regulatory body. If we look only at the phenomenon of the energy, at the energy converter, the case in point would be the battery for automotive. Well, there has been no emission from the battery run um, automobile, but if you come all the way from the generation and the manufacturing of the battery, then you can see there is a huge carbon emission. So we have to raise the visibility. That's what we are focusing on. Since we are an NGO, there is no profit seeking through IMO or UN agencies. We will release and announce the research outcome. And with that, we would be able to see the cost base as well as the pricing for fuel options. Then fuel ship needs to meet three requirements. The first is safety, and since a huge volume would be consumed, the economy should be guaranteed, and the availability should be high because vessel would navigate through any waters. A third is low emission or zero emission. These three requirements to be met, we need to have a certain level of production volume. No matter how good a technology is, if it's not fully available in terms of the quality and quantity, then there is no way for us to have a strong ecosystem as well as the infrastructure. That is why we need to closely collaborate and cooperate with the relevant organizations and the parties in this ecosystem. In particular, the economy is related to the profitability as well as the life of a business. So we need to objectify this kind of figure. Thank you.
답변 감사드립니다.
Thank you for your answer. Is there anyone who wants to jump in? I'm Byung Yu of
제가 짧게 말씀드린다면은 일단 질문은
HII.
아모니아를 우리가 열을
HHI, when we use ammonia as a fuel, toxicity and people's repurgin because of the odor would serve as the barriers to its market entry and penetration. That's my understanding of your question. In the carbon zero society, I do not believe there is one single energy or fuel. Ammonia is another type of hydrogen. I think, well, the question already answers itself because, like, when it can be properly controlled, then ammonia can be properly used. But as for automotive, which is more accessible to people and to the day-to-day lives, ammonia might not be that widely used. Because, first, the price. If we import ammonia and hydrogen, the economic analysis differs in terms of the result. But if you import ammonia and if you crack it into hydrogen, or if you import ammonia and use it as it is, in two different scenarios, the price would change differently. So if it is cracked with hydrogen, then it might not be competitive enough in terms of the price against liquid hydrogen. If we can use ammonia as it is, then this can be used for the economic benefits. So in terms of the risk management, ammonia is better. So in the case, rather than using it for automotive, of course we can use it after hydrogen cracking, but even for the hydrogen, well, there are all different types of hydrogen, such as hydrogen byproduct. So in this case, well, we can use the green hydrogen for automotive and ammonia for power generation purpose. Thank you.
Moving on,
강현수 교수님께서
Professor Hwang Il-sun
말씀을 해주시기 바랍니다.
will please give us the comment.
감사합니다. 저는 오늘 이
Thank you.
세션에서 C에 대해서 많은 것을
I
배웠습니다.
actually learned a lot about hydrogen in this session,
해양 조성 산업이
and
도와 소위
shipbuilding and marine industry
패러다임을 바꾸면서
is actually witnessing the paradigm shift in energy and massive wave of digitalization
시큐어
in order to have more secure, efficient operation and also to build global standards. I was very impressed by the presentations. I actually prepared a few slides in order to talk about the small module reactor based vessel development. So, to achieve carbon neutrality, I believe countries around the world have to engage in 30-year war, let's say. And the answer lies with the oceans. Norway produces the 100% electricity using hydrogen power. But I believe that we have to continue to explore ocean energy. So wind, solar, and also the uranium. We see that our next moving ground is ocean. So we have to extract the unlimited energy from the sea, because the uraniums in the oceans, they can be regenerated even after they are extracted. So it's virtually limitless. In the past, the nuclear power pursued the large scale for economic competitiveness, but in order to preserve the environment, currently there are efforts going on to produce small nuclear power modules. And plutonium does have a very long half-life, so even after 100,000 years down the road, it can still be utilized for a nuclear bomb, and therefore it has to be completely burned. And for this, the small-scale nuclear power reactor is the answer. So that's what it changed in the nuclear power sector today. This indicates the Industry 4.0 and COVID-19 and how they affect the shipbuilding industry and how they cause the so-called reshoring phenomenon in the shipbuilding industry. In other words, return to home base, especially the China and Russia are strong competitors of Korea. They are actually developing the floating offshore power plants, and China is also building infrastructure for this, and the US, Denmark, France, Italy, you see that they're all stepping up efforts to develop maritime nuclear power. And thankfully, the UNIST, CAPCO, and also some other organizations in Korea are also joining forces to develop the engines for maritime nuclear power. And every 5 years in nuclear power sector, we developed the plan for promotion, and we included the maritime nuclear power development in the plan. So for the next few years, we will focus on R&D, and the global acceptance is the minimal, and therefore we will focus on producing hydrogen using saline water, and also the imported ammonia can be utilized by nuclear power plant to produce hydrogen at a low cost. So by 2040, our goal is to establish legislation and develop the nuclear power fueled ship. But in military sector and the defense sector, you see that there are already the nuclear power fueled ships that are available. But the technology so far that we utilized is the light water system. Whereas in military application, what they use is heavy water system. But IAEA for nuclear control, the concentration limit threshold is 20%, and therefore the nuclear power merchant ships and commercial vessels, they have to replace nuclear fuels regularly. But in that process, there could be the accident of explosion and detonation. So Denmark currently developed the liquefied nuclear power system, but this is very susceptible to safety accident. And so it is pretty dangerous, but if you could use lead bismuth, then once you fill the nuclear fuel, it can be operated for decades. And this technology was developed for the first time in the world by UNIST. And currently, we are pursuing projects involving this technology. But what's problem is the legislation. As we experience the Chernobyl crisis as well as the Fukushima crisis, the IMO safety code is not revised, but this code has to be revised in order to commercialize innovative technology. And also, countries around the world should allow the entry of nuclear power fueled ships. So I would say legislation is the most significant barrier. So for that, I believe that we have to continue to make efforts so that we can give and we can earn trust from the public about the safety of nuclear power. Because Korea is poorly endowed with natural resources. That's why Korea was able to build strong nuclear power competency. And when it comes to shipbuilding industry, Korea is an undisputed leader in the world. Korea is very aggressive. And I believe that there is really a synergy between nuclear power and shipbuilding. And I believe the partnership is seriously required in order to achieve carbon neutrality. So if we could have solid partnership, I believe that this will contribute greatly to the achieving of our goals by 2050. And once again, it's my honor to be part of this auspicious panel. Thank you.
Thank you very much. After 2040, another fuel will be pondered and developed. And he also mentioned how to use this new alternative fuel for the maritime industry. Now I'd like to turn to Dr. Lee of Korean Register for his question. Thank you. My question, I'd like to say that I'm totally in agreement with what Mr. Yu said and Mr. Kim said. Myself, I have researched renewable energy for the past 20 years. As the professor just mentioned, as I have worked on the renewable energy, I have confronted the dichotomous approach that the nuclear power generation is evil, while renewable energy is good. But such A dichotomous approach is not right. That's what I have realized because the renewable energy can exert can realize its full potential only when it works on top of um, fossil fuel, the nuclear power, and LNG.
120기가 정도 용량이 되는데 여름에 그 과부하
And
하이드로 프로젝트만 97기가까지 올라옵니다.
well, we
그러면
have
예를
installed
들어
capacity of
이거는
wind power.
중에서는
As for Jeju
원래는
Island,
설계
at the maximum
시기에는
level, the
4기가
renewable
되겠다고
energies
봐야 되거든요.
installed capacity,
운영되는
well, it can
기준으로는
produce as much as 93
4기가
gigawatt.
그렇지만
Well, its usage is
해수부터는
very low, but when it comes to
0.7기가
Jeju Island, it it uses only zero point
그러면
0.7 gigawatt.
1% 이하의
So
수요를
it
가지고
accounts
있는
for
거죠.
less than 1%
이런
of
상황에서
the energy mix
지금
of
계획된
Korea.
게 4기가 이상의 풍력과
But
태양광을
the
가지고
plan
있는
is
거거든요.
to
이거는
um,
언제부터 들어갑니다.
raise the level
그러면서
to
이거는
over
이
4
나누어서
gigawatt.
얘기를
So it
이거를
has
수소로만
excess
생각하면
electricity. So
수소로만
Jeju Island wants to use
수소에서
water
만드는
electrolysis to
문제는
generate
쏟아지는
hydrogen. But there is another
그런
problem.
수소에 사는
Jeju
시간이
Island has no place to use
이
and consume
생산량과
hydrogen. So
소비의
production
비율을
and
따라가지
consumption
않는다는
are
거죠.
mismatched here in Jeju
그래서
Island.
지금까지 또한 또 내년에부터
So from next year onward,
글로벌 파일을 말씀드리면 22년부터는
from
수소로 가야
2022,
할
hydrogen law
수소가
will be
되고
enacted.
현재 신재생 에너지는
As
별도
for
포함되어 있습니다.
um,
RPS처럼
renewable energy, there is
유니온이 따로
RPS,
있거든요.
and hydrogen will have its HPS. So power
수소로
generator needs to use hydrogen for power generation. So from next year, HPS will be introduced. So there is an increasing demand of hydrogen,
수소의 수요는 늘어나는데
but
수소
while there
생산이
is an
언제부터
rising
시작될까요?
demand,
수전에
there is a limited
영원을
supply.
만들었을 때
If
분명히 남는 게
electricity
남는 좀 만들었을 때
cost
영원을
would be zero for water electrolysis,
원소에서 축적하는 그 수전액의 단가는 킬로그램당 14,000원.
per kilogram in Gangwon, it's 14,000 Korean won. In Jeju, it will be 8,000 per kilogram.
지금 현재
I don't think that really makes sense because hydrogen fueling stations, you can see whether you can recharge 1 kilogram by at 7,000 or 8,000 Korean won. So in that case, water electrolysis is not a viable option. So I believe as for hydrogen, we would need to import it.
큰 부분에서 많은 내용을 말씀하셨는데
Hyundai Heavy Industry presenter shared with us various ideas. I think hydrogen,
수소 추진 상납도 가져가려면 미국산의 수소의 수요가 더 많을 거라
I
생각합니다.
think we have a higher onshore demand for hydrogen than for the offshore. So I think the key here is how to import, how to bring hydrogen into Korea. So I'd like to ask for any kind of plan whether you have when it comes to importing hydrogen. Would you please address the question? Thank you for your question. The three panelists, there are two things in common. One is related to safety, the other is hydrogen production. So these are two common things we can see in the three questions. As for the safety, when we have an alternative fuel, I think, the key is economy and safety. Unless it is safe enough, then there is no way for you to use it, no matter how good its economy is. In case of LPG, the biggest concern was that since LPG is heavier than LNG, that might cause some suffocation. But that was successfully tackled through ventilation and very other technology. So as for ammonia, as for the nuclear power generation, as for ammonia compared to methane, its ignition energy is very high, so it has very low risk of explosion, but it has such a concern over toxicity. That is why various safety measures need to be introduced. But if we have successfully introduced them, then we will be able to use them in a safer way. And many countries have came up with regulations when it comes to ammonia. And from next year onwards, there will be a revision of regulations regarding the use of ammonia as a ship fuel. As for nuclear power generation, the one is the propulsion using it, and the other is power and hydrogen generation using nuclear power. And as for propulsion, that is available only for military purpose, but not for international navigation. It needs to meet the requirements of the IMO. Since there are so many stakeholders involved, it would be very difficult to create any an agreement as to that. And it will take such a long time to create any such IMO code. But as for icebreakers, since they would navigate only within the national boundaries, in that case, it will be possible. If a subscale nuclear reactor is used in Korea, then since there is such a fluctuation of the offshore renewable power generation using offshore the power generation facility, then you can use it as MI has such a high level of safety as compared to the existing nuclear power generation. And since it is located in offshore places rather than onshore, then we can successfully address various complaints from the residents. Then what about the import of the hydrogen? So the generation of the renewable energy within Korea might not be enough. I'm sorry, the generation of hydrogen using renewable energy might not be enough. So we would have to import it through various elements of the portfolio. And we would have to identify various sources for the input. There should be a liquefaction plant, and there should be an ammonia carrier to carry the hydrogen to Korea. And there must be some downstream plant and still making facilities. So all these factors need to work in harmony in order for us to make a decision to import hydrogen in high quantity. So we have to take all this into consideration to come up with a balanced plan. That's the role to be played by the government as well as by the industry.
So thank you very much. Um, Director Yu, please keep your remarks short. So I believe that I think that you asked about the technology development plan for the liquefied hydrogen transportation. So you cannot really we don't really have to stick to liquefied hydrogen only. Ammonia can also be a solution. So ammonia right now we do have the solution, but for liquefied hydrogen, it's a kind of ready to made solution. So if there is a request from the shippers or the cargo owners, then we can develop the technology. So the speed of technological development, yes, that's important, but what's more important is with the market selection and demand. And if there are regulation and strong motivators, then maybe we can join forces together and facilitate the technological development. So thank you very much for the answer. We are now having very heated discussions, and we are also talking about new technologies and innovations. So we do have a lot of questions and comments to make. So far we have heard from the three panelists. If you do have more questions, then we'll entertain that from panelists first. And so regarding the hydrogen, there have been a lot of researches going on. And also during the research and the investigation phase, especially the advanced nations in Europe, including Norway, Germany, France, these advanced nations are financed, they are providing the financial assistance to conduct the basic research, and they also operate demonstrators, though in small scale. And so they are exploring these innovations at full speed. And Korea, we do have a lot of discussions and there are a lot of attempts. But the problem is that there is no significant appropriate adequate financial assistance for basic research. For materials, I think we do have more active discussion and programs going on. But I believe that these vessels these aqua vessels should go large scale eventually. But there are no shipbuilders in Europe, so the shipbuilding needs to be taking place in Korea anyway. So in that sense, I believe that we should combine the basic technology that European countries have developed as well as Korea's shipbuilding expertise. I know that it's still too early, but maybe we can start discussions on how to promote partnership with European countries so that the whole countries around the world can move together in tandem globally and to conduct researches. I believe that this will benefit the welfare of human
예,
beings.
감사합니다.
Thank
오늘
you.
앞에서 많은 그 문제의 경제성이나
So many presenters and panelists talked about economy as well as safety.
그렇지만 우리가 앞으로 이런 친환경 선박 축제에
But
배탄소
in this
온실가스를 대비하는
era
시기에
of green ships and
많은
as we prepare for carbon neutrality by 2050, enormous investment would be required. Economy is very important in this regard. However, there are other areas of concern we have to take into consideration. That's why intergovernmental and between research organizations and between industries and among all those who are involved need to closely cooperate and coordinate with each other in order to come up with a tangible solution. It's almost time for us to close.
온라인에 질문이 많이
There are
올라왔는데
many questions
그 한 가지
posted. Let me ask one of those questions
사실은
posted online.
선박, 친환경
The
선박
smart ship
방식도
and
모두 다
the eco ships.
스마트화돼 있고
This is the
디지털라이제이션을 하는
direction
거죠.
we are moving
근데 이에
in.
따라서
That all
굉장히 빠른
ships
시간
are
내에 진행될
going
것으로
digital and
보이는데
things will be
지금 로봇을
accelerated
도입되고
when we do the remote operation and remote control.
지금 디지털 컨트롤을 위해서
And through the digital control,
선박의 대열을 실시간으로 할 수가
satellite
진행되고
control of
있지만
ships will
우리가
be
그렇게 하기
done
위해서는
sooner or
많은
later.
사용하기
But
위해서는
in order to do this,
사이버
we
시큐리티가
would
굉장히 중요하고
also consider
현재
cybersecurity,
운항중인 선박의 해상법의 많은
especially
변화가
the rules and regulations, maritime rules and regulations need to be updated and revised greatly.
아무래도 이제 기전이라든지 아까
So whether it's
말씀하셨던
parts and components or various systems which will be incorporated into the system, we would have to consider digitalization and digitization. So with regard to that,
이런 부분은 어떻게 연구를 하고 있고 어떻게
would you
생각하시는지
share with us the status of the research regarding these areas? Each speaker and presenter, you have only 1 minute. You made a very important point. So far, we said that the ships have been kidnapped in Malacca Strait by pirates, but these days hackers would kidnap and hijack the vessels going forward. That refers to the cyber hacking. That is why not just the connected equipment, but connected ships have been highlighted. The ships have been connected online all the time, 24/7, so it is exposed to any cyber attack. And autonomous operation system might malfunction, and the people on board might not be able to run the system inside the vessel anymore. That is why cybersecurity, especially for the vessels and for the equipment on board, is so important. And I recently heard that the Korea Maritime and Ocean University has created a cybersecurity department, has a plan to create a cybersecurity department. But even from the stage of manufacturing and designing parts and equipment, cybersecurity should be considered. Only then we can have heightened level of security for the entire vessel.
말씀 다 옆에서 잘 말씀해 주셨는데요.
As Professor Lee mentioned,
방어학에서
so you have the whole
의식
piece
되고 있습니다.
by putting together the
트랜스포메이션을
pieces.
했을 때
So when we talk about digital transformation,
디자인을 해보고
that's something we can realize only when each and every part of the vessel is digitalized. That is why, in that regard, we definitely need to have and incorporate the cybersecurity feature. Thank you.
시간이 많이 지난 관계로
So
여러
because of the
가지
time constraint, we actually wanted to give the opportunity
시간을 추가로
to Professor Yi for his comment,
또 오늘 어느
but
때보다도
maybe we could not.
여러분의 열띤 열정적인 강의
So once again, I would like to thank the
또 모든
presenters and panelists
진심으로
for their
감사드립니다.
passionate participation,
온라인 오프라인으로 함께 해주신 모든
and
분들께
also the participants online and offline. Thank you very much for your time.
어느 때보다도 2021년도 세계관 포럼의 조선 세션이
I believe that the shipbuilding session of the 2021 World Ocean Forum truly had a very rewarding and fruitful discussion.
진심으로
Thank you very much.
감사의 말씀을 드리겠습니다. 이것으로
With that,
오늘 조선 세션을
I would like to conclude the shipbuilding session. Thank you very much.